This section has an amazing title. Factoring a squared f of x squared minus b squared g of y squared, where f of x and or g of y are binomial. Clears things right up, doesn't it? What they mean is sometimes you have to factor something which is a difference of squares, but the pieces inside the square are not all that obvious. This, if you look at it the right way, is exactly what a difference of squares is supposed to be. It's got something squared minus something else squared, and that means we know how to factor this. Just like any other difference of squares, you put in two sets of brackets. One gets a plus, and one gets a minus. It's just the things that go into these spaces are going to be a little more complex than we're used to seeing. The first thing was a squared. Its square root is a, so that goes in the first places. Easy enough. The second thing was b minus c, and so that has to go in the second place there, and it has to go in the second place here. There. So a squared gives us a times a. B minus c squared gives us b minus c times b minus c again. Now, this set of brackets is not really important. You could take or leave those. If you wanted to write this a plus b minus c, that would be perfectly fine. But these brackets are very important. Do you see why? They're important because they make this negative distribute through the b and the c, and that does have to happen. So the right way for this second part to turn out is a minus b plus c. If you don't have the bracketing, this will not turn out right, and you'll be sitting there wondering why your answer is almost like the one in the book, but not quite. So, just difference of squares, only with bigger chunks. Here it is again with even bigger chunks. Let's make those disappear for a moment. Okay, now you can see that once again, yes, this is a difference of squares. It's something squared minus something else squared, and that's all we really require. So the factorization should be plus, minus, and now what goes in the blanks? The first value is 2x minus y. That goes here and here. The second chunk is x plus y all squared, so in both of these places we're going to put x plus y. X plus y, x plus y. Now, you could bracket all four of these, and that's really not such a bad idea. It makes it much more readable. It keeps you from, makes it easy to see that this piece broke up into that chunk and that chunk, and the second part of the difference of squares gave us this chunk and this chunk. Of those sets of brackets, this pair is not strictly necessary. Neither is this one, neither is this one. The one which is critical is the one after the negative sign. You absolutely must have this set so that this negative sign distributes correctly. So I'll drop the ones that are not essential. We have 2x minus y plus x plus y. Here I'll drop this pair, which are not essential either, 2x minus y. And the pair that you must have is the pair that makes this negative go on the x and also distribute onto the y. Okay, now we can clean these up. 2x plus another x makes 3x. Negative y plus y, oh, is just gone. That's unusual, but it's kind of nice when it happens. In the second set of brackets, we have 2x minus an x, and we have minus y and then minus another y. So there it is, completely factored. If you wanted to dump these brackets around the 3x, you could do that as well and simply say 3x, x minus 2y. That reads a little bit nicer and means the same thing.